In this video, I'm going to be describing how to construct polynomials when given their main features, and more specifically, how to construct them when given your exact zeros. So to start, let's go over the basic features of polynomials that help you construct a rough graph or equation for the polynomial. The degree, which is the highest exponent in standard form, or the sum of exponents in the factored form. This will help you determine whether it's even or odd, which helps you see if it's pointing up like a parabola or down in the case of negative, or if it is going as such when even or when odd and positive, and then when odd and negative. And that comes with the end behavior and zero behavior, which shown here in a smaller view, where it's up, up, even, down, down, even, and then down, up, odd, and then up, down, negative, odd. And for the zero behavior, we can tell when it is even. For 1, 0, it'll be touching at that 0, the x-axis point, and when it's odd, it will be going across. But when it comes to constructing it with the x values, it's more different and more specific, rather, because you are using actual points to construct the actual equation. And down here you can see for linear equations, you just put them in standard form, and then you remove any fractions by multiplying the denominator by the equation. And for quadratics in standard form, you multiply and combine like terms. But for polynomials, you sort of combine both of them, and if there's fractions, you just multiply. If there's a fraction as a 0, you multiply by the denominator for that specific 0 to get an ax plus b equation. And then you multiply and combine like terms. So for example 1, it says construct the lowest degree polynomial given the zeros below. And we have -5, -3, and -4. So to start, we are going to put these zeros into factored form, which will be x plus 5, x plus 3, and x plus 4. Now we're going to multiply and combine like terms, but start with just one or two terms and leave out the third one for the next part, so you don't get too confused with too much multiplication. So you can have x squared plus 3x and plus 5x plus 15. And then x plus 4. Before you multiply these two out, combine like terms. And now here you can multiply both terms together, but since one has 3 and the other has 4, it does end up becoming a little more difficult, which is why you can create a chart to help keep track of your multiplication. So we're going to have x squared plus 8x plus 15 and x plus 4. So here you can do each multiplication for each term in each box, and it helps you just keep track of each like term and which ones are not, and how to get more accurate multiplication. So here we're going to have x cubed, 8x squared plus 15x, and then 4x squared plus 32x plus 60. So here you can combine like terms. You'll get 12x squared. Then here we'll get 47x plus 60. And here is our polynomial constructed with the zeros we are given here. And so using that, it's pretty simple to create the polynomial. And this one is more accurate instead of using degree and n behaviors to just create either a graph or a rough equation that can be used any term or any degree, just shows the direction and behaviors. I also included this equation as well, or this example, to show what to do when given a fraction and and in this case, a complex number. So in these two, you see we have only two terms, and before we had three. But here, when given a complex or irrational number, they come in conjugate pairs, which means that when given a number like this, you can assume that its conjugate pair is also a 0. So in this one, we're going to have x minus 5 plus the square root of 5. And then for the conjugate, we're going to have x minus 5 minus the square root of 5. And then you can parentheses these to make it a little more organized and easier to see. And then for this fraction here, you're going to multiply by the denominator while it is in factored form. I'll show you here. And you'll end up with 9x, and this will become positive, plus 6. So this is a lot of numbers here, and it can be really confusing, but you can also use the table. It's a little off. Do it on this side for the first two terms, and it will make your life a lot easier. So here you can have x minus 5 plus square root of 5, and x minus 5 minus square root of 5. And then you just distribute these terms out to each other. Squared minus 5x plus square root of 5x. And then this is negative 5x, 25. This is negative 5 plus radical 5. And then negative radical 5x, negative 5 minus radical 5. And we have negative radical 5 plus radical 5, which may will be negative 5. And here you can see that when you multiply by conjugates, you get a lot of terms that cancel out, such as here, here, and that's pretty much it. So then you can write out your new term here while combining like terms still. You get negative 10x and plus 20. And then you can write your other equation or other 0, and then write another box for this one. And by writing these boxes, it helps keep track of your multiplication. I find it a lot easier than trying to do it by just distributing normally. So here you can now get the final polynomial. Won't forget that x. And here we can now get our final polynomial. So when it comes to fractions and irrational and complex numbers, it looks a little scary, but when you know you can use the conjugate pair and you know how to get a fraction into a easier zero, then it makes everything a lot easier.